Hi everyone, in this video I'm going to show you how to create a document in Python as well as continuing the two operators, which is modulus and floor division operator. So as you can see here, I'm in my Python 1 folder. I've opened my folder Python 1. How I'm going to do it is I'm going to hover over the new file button and it's going to show you this text button. We don't want a text file, we want a Python file. So what we're going to do is we're going to name it. I'm going to name it m and mfg under and then .py, which is your extension. Notice how your logo changes. That's what you want. You click enter and there it is. So in this video, we're going to be talking about the modulus and floor division operators. So let's go over the basic definitions of each of them first. So what the modulus operator does is it returns the remainder when two numbers are divided. Now let's go over what the floor division does. The floor division returns when two numbers are divided, rounds down to the next lowest integer. So now since we have like the formal definition of both of these, let's get into looking at actual examples of them. So I'll just use my variables from here, I, j, k, l, m. And I'm actually going to remove k and l and just use I, j, and m as my variables. Now, just as a quick reminder from our previous video, these are global variables, as they can be accessed through all blocks of code. So now let's get into looking at what our modulus divisor does. Sorry, modulus operator. So the operator assigned to this is the percentage sign. So you click Shift and 5 and you get your modulus part. So the first thing we're going to do is review basic division, right? So basic division would give you, say you want to divide 30 by 10. Or in other words, say you want to do I divided by j. Remember our division operator, /. The computer translates that to 10 divided by 30. So, which would in turn result in 0.333. This is actually the opposite of what I wanted to do. I wanted to do I divided by j divided by I. So that's going to be 30, and this is going to be 10. So in turn, this is going to go to 3. But what if when we have a remainder? So as we saw, when I flipped the 2, we got a decimal value. So how do we deal with that? Say we have I divided by j this time. How are we going to approach it? Or more importantly, how does the computer approach it? So let's try this out, right? So let's say print I divided by j. What is the result? It's 0.0.333333333. So another thing to point out here is if we had made this, say, k is equal to I plus j, and sorry, I divided by j, k, and we wanted to print k. Remember that since variables are dynamic in Python, the code changes the data type of the variable to double for you, unlike Java. So when we print this, now back to modulus division. So let's go over mathematically what's going to happen, right? So when dividing 10 by 30, it's not completely divisible. So what you're going to do is you're going to have a remainder of 10. So let's write that out, right? Mathematically, what goes on is that you have 10 divided by 30. Since it's not divisible, you will have a remainder of 10. So what the modulus function does is it prints that remainder, or it returns that remainder more correctly. So, for example, since 10 is the remainder here, the modulus function would return the value 10. So let's notice and see what happens, right? So let's determine another value p, I divided by j, but not instead of divide, we're going to do modulus j. So what we're going to expect from the computer is to be returning 10. And we're going to print p, and let's see what happens. As you can see here, it returned 10. So it basically returns the remainder. Now let's think about this. Why in the world would you want to use the remainder of things, right? Well, actually, there's a very fundamental use for this, and it's determining the use of modulus is to determine whether a number is even or odd, or is a multiple of a number. So let's take a look at that, right? Let's create another function. Let's say we create a function def even underscore odd, right? And we'll take the input of n. So then what we're going to do is we're going to write an if function here. Let's say the purpose of this function is to check whether the given number n is even or odd. How would we do that, right? So what we're going to do is essentially what we're checking is when we divide n by 2, or when we're splitting the number into two pieces, are there a remainder? Is there a remainder, right? So the remainder function is modulus. So let's write that out. If n divided by 2, or n percentage 2, which is basically n modulus 2, which means if n, check for remainder, if n divided by 2 returns a remainder of 0, remember the equality checker? It's not assigning, it checks for equality, then return, or print, my bad, print even. Else, print odd. So let's think about, so if you know that there's a syntax error here, there's supposed to be quotation marks around strings. And since odd and even are not variables, they're supposed to have a quotation marks around them. Okay, so let's think about what's happening here, right? When we divide a number by 2, you're either going to get a remainder or you're not going to get a remainder. You're going to get a remainder of 1 or you're going to get a remainder of 0, right? So what this function is doing is it's checking if n is divided by 2, returns a remainder of 0, it's going to print even. Else, it's going to print odd, because the only other possibility you have here is n modulus 2 gives you a remainder of 1. So let's call this function. Let's test it out. Let's write some test case steps, right? So even underscore odd, and let's say we will do number 3. Ideally, this is supposed to print odd if I wrote my code right. And indeed we did. So let's test it out. You should always test your code out multiple times. So let's test it out with the even number this time. Let's make it 6. And it prints even. That's great. So we know that our code is working. So now that we know essentially where modulus is used, we can move on to floor division. So what is floor division, right? Floor division, the operator assigned to this is 2 forward slashes. So essentially what this does is it's going to round down your number. So floor division divides two integers or two numbers, and whatever the result is, so say you have, let's go back to our example of, my bad, 10 divided by 30, which resulted in 0.33333333, right? So this is if we use the normal division function. See how we use the normal one? What floor division would do is it would return the next lower integer. So let's write that out, right? So say we had 10 floor division 30, it's going to return 0. So it's basically going to return the whole number, right? So if you don't want any decimals, you usually use floor division. So let's look at another example, right? Let's look at our example of 10 floor division 7. When you divide 10 by 7, let's search up the answer because I can't memorize what the remainders are. So you would technically, if you just use normal division, you'd get 1.428 by 7, yada, 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 right? So what, oops, my bad, Control X, 7, right? So what this does is it returns that value. But when we use floor division, the next lower integer after 1.4, what rounds down, is 1. So let's write that out. So 10 floor division 7 would return 1. So now here brings up a key point. What if our number that we divide by returns a number that's usually rounded up? So let's say we give an example of 3 divided by 5, right? So let's say we have 3 divided by 5. This would usually return 0.6. So intuition tells us that when we have this number, we have to round up, right? It's over 0.5, it's supposed to be rounded to 1. But that's not how floor division works. You will always round down. So it's very important to note that floor division will always round down. So what floor division will return here is 3 divided by 5 equal to 1. That's what this returns. Sorry, my bad. 3 divided by 5 will return 0. Floor division, my bad, will return 0. That's the specialty of floor division. So let's work out a few problems with this, right? We worked out quite a few here. So let's just use whatever we have left. J and M, right? So let's create another variable t. And that's equal to J floor division M. So what we're expecting from this code is we're expecting 30 divided by 7, floor divided by 7, which if you just did 30 divided by 7, it would be equal to, let's calculate that, 30 divided by 7, 4.285, right? So 4.2857142.9, etc. But with floor division, since we always are rounding down, you would have to, the floor division would simply return 4. So this is what we're expecting. Let's see what the computer prints. You can see here, it printed 4. So that's the specialty of floor division. So, and that's pretty much it for this video. If you have any questions, please feel free to put them down in the comments and I will be sure to answer them for you. And yeah, thank you so much for watching. Have a great night. Bye.